The topic of this video will be predicting whether E1 or E2 mechanisms will predominate. Just like with SN1 and SN2, it's useful to be able to predict whether E1 or E2 will predominate because it better allows us to predict what the products will look like in terms of stereochemistry and also in terms of whether rearrangements can occur. Also remember that when we're talking about whether E1 or E2 will predominate, what we're really talking about is whether the E1 mechanism or the E2 mechanism will happen more quickly. We're looking at the rates of these mechanisms and how all of the pieces of the reaction will affect the rates of E1 versus E2. Finally, remember that E1 and E2 compete with SN1 and SN2. So we're not really thinking about whether E1 or E2 will predominate. We're really comparing all four mechanisms and deciding which one or multiple mechanisms will predominate. But in this particular lecture, we will focus on distinguishing between E1 and E2. First, we'll look at the effect of the base. The effect of the base on rate is the most important factor in determining whether E1 or E2 will predominate. Just like with SN1 and SN2 and the nucleophile effect, the strength of the base affects the rate of the E2 mechanism, not the rate of the E1 mechanism. Remember that the E2 mechanism is bimolecular, involving both the base and the substrate, while the E1 mechanism is unimolecular and only is affected by the substrate. Therefore, the strength of the base affects only the rate of the E2 mechanism. Therefore, a strong base promotes the E2 mechanism. Remember that most strong bases are also good nucleophiles, and so sometimes SN2 will compete with E2. If our base is weak instead of strong, we will typically see that E1 predominates. This is not because a weak base promotes E1, but because a weak base slows the rate of the E2 reaction so that the E1 reaction becomes faster. Also remember that typically when we see E1 occurring, we will also see SN1 occurring, because most weak bases are also weak nucleophiles. Next, let's look at the effect of substrate structure on the rate of elimination mechanisms. Remember that the substrate is involved in the rate-determining step of both the E1 and the E2 mechanisms. Therefore, the structure of the substrate will affect the rates of both of these mechanisms. Unlike SN1 and SN2, the order of reactivity for the substitution of substrates is the same for E1 and E2. For both of these mechanisms, tertiary substrates will react most quickly, followed by secondary, followed by primary. However, this order of reactivity is observed for different reasons depending on whether the E1 or the E2 mechanism predominates. The E1 mechanism favors tertiary substrates due to the stability of the tertiary carbocation. Tertiary carbocations are more stable than secondary and are more stable than primary. The E2 mechanism favors a tertiary substrate due to the stability of the alkene product. Remember that more substituted alkenes are more stable. Finally, let's consider the effect of solvent on the rate of the E1 and E2 mechanisms. Both E1 and E2 mechanisms prefer polar solvents because the reactants are typically polar as well. The E1 mechanism, like the SN1 mechanism, involves charged intermediates, and therefore also prefers protic polar solvents. Because the E1 mechanism involves charged intermediates, the transition state also has a significant amount of charge, and polar protic solvents are better able to stabilize that transition state. Stabilization of the transition state lowers the activation energy, increasing the rate of the reaction. The rate of the E2 mechanism is much less dependent on solvent. However, like SN2, E2 reactions favor polar aprotic solvents. These solvents are able to solubilize the reactants, but don't protonate the base, therefore allowing the bases to be stronger, which favors the E2 mechanism.